Hello everyone, welcome back to another remote sensing lecture video. And in this lecture video, I want to give one last set of examples of contrast stretching. But in this set of examples, I want to do it a little bit differently in the sense that before we've been talking about a single band. But ArcGIS Pro and other remote sensing software, they do all three bands, right? Going back to that idea of band assignment. Right, they do this for all three bands and then combine those together. So you get this sort of effect of having all three bands being contrast stretched, not just the one. So I want to go through all four examples. I'm going to go through them a little quicker. I'm not going to talk about them as much. I just want to show you what this looks like using three bands instead of just one. So this is the first example. And in this case, our band assignment is 1, 2, 3. So both of these are blue, and this is a green band. So the way that this is the histograms as they would be shown in ArcGIS Pro, and this is the resulting image. So this is, again, this is none or no stretching. This is no stretching. And so what happens in this, in the way that they set up their stuff, these gray histograms, these are the actual image histograms in pixel values. They have then superimposed on that the colored histograms, which are the display values. So it's a little confusing because you have two different axes, right? This is zero display. This is the theoretical minimum. This is the theoretical maximum. And then this is the actual histogram. And this is how that would be transitioned to display values. Now, what I want to say about this particular image is this is what is called a signed 16-bit. So that means that the theoretical minimum is actually negative 32,000. And we've already kind of talked about this. And the theoretical maximum is 32,000. So when you do the none, right, most of your pixel values are actually going to end up kind of in the middle because you're going from a negative number to 0 and a positive number to 255. Anything that was mildly positive is going to end up in the middle. So that's why most of these are actually going to end up in the middle here. And again, because all of these pixel values are basically the same, right? If you remember back to our first set of examples where I went through this band, right? We had 9 display values, right? All of the actual data mapped to 9 display values, which means there's 9 display values here, which is why this looks essentially like a gray box. So if you were to open this, and you might say, I think I've ruined my data. I've corrupted something. You haven't. You just likely have a no stretching contrast stretch. So next example. This is the MinMax. So the MinMax stretch, you'll see, actually makes the data look a lot more like the image histogram. And you can see the image is a little bit brighter, but still not super useful. It's still really dark. And that's because we have pixels with extremely high pixel values up here. Okay, so again, we're doing all three bands, right? In this case, we're applying that concept of contrast stretching to all three bands, not just one. Let's look at one more example. So this is now percent clip. And you can see here that we've started to pull the display value histogram. Is starting to pull out and be a little more spread apart. The bulk of the pixel values is starting to move towards the center of the display values. And you can see as a result, right, our image is starting to get a little bit brighter. Again, this is percent clip. So let's write that down. This is percent clip. Okay. And then finally, this is standard deviation. And you can see now that we've really pulled the middle of the data to the middle of the middle pixel value. The middle pixel values to the middle display values. And we've made the image a lot brighter as a result. And again, this is what I was saying. When you use standard deviation and you go from the middle out, you have a tendency to end up with a lot more dispersed display values than with percent clip when you go from the outside in. You're still going to improve the image drastically, but you're not going to get as bright as you do with the standard deviation. So hopefully this makes sense. I know this was a shorter video. I know I didn't talk a lot about the specifics, but I just wanted to, again, just reiterate conceptually what the histogram stretchings do. If any of this didn't make sense, please reach out. Thank you.